In general, the equation y equals sine of x minus c or y equals cosine of x minus c are known as the arguments of the function. The x minus c corresponds to a phase shift or a horizontal shift of c radians. To graph these functions of this type, a table of values with 3 columns is used. The first column is for the variable. The middle column is known for the argument. So we're calling this here the argument. It's kind of like in Algebra 1 where you called that part the quantity. Now we're calling it the argument. Okay? Note, use only the first and last columns to graph the functions. The numbers in the middle column ensure that the graph will have one complete sine or cosine wave. We're actually going to draw 2 waves. I'm going to draw the one wave and then infer the second wave from the first, just not from my knowledge of the sine and cosine waves. So basically what I'm going to do is write down my standard range values for sine, 0, 1, 0, -1, and 0. I'm also going to write it down for cosine, 1, 0, -1, 0, 1. Okay, I already graphed these functions, but these are horizontal shifts. So what we're going to do is use this argument and our x values, the new x values, and graph only this x and this y. Since this x has to be equivalent to the 0 here, I'm going to say what radian minus pi over 2 equals 0? And the answer would be pi over 2. So you're going to add pi over 2 to all of these. So when I add pi over 2, I'm going to get pi over 2 because pi over 2 minus pi over 2 is 0. So I'm going to add pi over 2 to pi over 2, and that's pi. And I'm going to add pi over 2. Remember, we're adding 9 degrees. So all we're doing is going to be bringing down, this is by 90s, right? So all you're going to do is just copy down the next one. So this is going to be 3 pi over 2. It's going to be 2 pi. And now what I have to do is add 2 pi plus pi over 2. So that's going to be 4 pi over 2 plus pi over 2, because we have that same denominator, which gives me 5 pi over 2. Okay? Now, and we're going to graph these. What we're doing is we're shifting to the right by pi over 2 radians, or 90 degrees. On the cosine, we're going to shift left by pi over 2. And I asked myself, what radian measure plus pi over 2 gives me this 0? So basically, you're going to subtract pi over 2. So I'm going to subtract pi over 2 here, get 0, and then you're just going to subtract. Now, these are the values we're going to have for one wave, and then we're going to infer the other waves. So we're shifting to the left. We're going to be shifting to the left on cosine and to the right for sine. And these are the values you're going to use, and know where we're going to start. We're going to start at pi over 2, and we're going to end at 5 pi over 2, which, by the way, is 450 degrees. All right, so let's go and graph it. I already graphed the sine wave, and they only want one wave, or we only made a table for one wave. So basically it means I'm starting at pi over 2. So I'm putting my 0 here, and then I'm going to draw my dots. And that's why I started with the dots, because if you get the dot thing down, then you don't have to stress so much. I'm going to do dot, 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 dot. And if you notice, we don't have this labeled. So I'm going to go down here and draw it. And this is going to be 5 pi over 2. Okay? If you want, you could call this pi over 2. Let me do it in a different color. Pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, and then 5 pi over 2. That helps sometimes when you're trying to label your graph. Okay? Now to infer the other side and go to the left here, I'm just going to go back and draw my dots. So if I just want 2 ways, I'm going to go back and draw it, but I'm going to end at negative 3 pi over 2. Okay? So the whole thing was shifted to the right by pi over 2, or 90 degrees. Okay, for cosine, I took the liberty and drew the parent. Oh, did I write this down? This was y equals sine of x minus pi over 2. It's just like your horizontal shifts you did in Algebra 2 with other functions. Okay, this one's going to be y equals cosine of x plus pi over 2, which, by the way, is really y equals cosine of x minus a negative pi over 2. There's where the left part comes in, because you're taking the distance from 0. So we're starting here at negative pi over 2. Well, we're going to start here because it's cosine. I always want to draw sine, sorry. All right, so sine's my favorite. So I'm going to start here and then just draw my dots. So you're going to make your V shape, and you're going to start dot, 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 dot. Notice that we're stopping at 3 pi over 2. And it depends on if you're taking a test what the teacher is asking for. If they want you to go from negative 2 pi to 2 pi, then you just go all the way to 2 pi and stop. But if they just want you to draw 2 waves like we're doing, then you might want to do it the way we're doing. And then I'm going to go on this other side and draw my dots. So dot, 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 and I need one here. As you recall from our cosine graph, this is negative 5 pi over 2. Okay, so we're going to continue this on, and there's my 2 complete waves. We shifted the whole thing. That's not very good. All right, we shifted the whole cosine graph to the left by pi over 2 radians. Okay, the next few videos are where we're going to combine everything together. Amplitude, period, new center line, and phase shift. And you're going to find that what's going to happen, the hard part's going to be combining the phase shift with the period. Okay.